Hello, this is 5-4 in geometry. Last class we just talked about how to do triangle congruence proofs, and today we are going to focus on CPC-TC, and I'm going to go over what that means here in a little bit, but let's just go ahead and write down our learning intention to start us off. Learning intention, I will learn how to prove sides and angles of a triangle congruent and I will learn how to use CPC-TC. Okay, just a reminder that it has named the 5 ways triangles can be proven congruent. So we have lots of options. If you guys remember, go ahead and pause this video really quick and try to fill that out by yourself. Otherwise, I'm going to continue on and give you the 5 ways. So side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. And then the 2 ways that we can't prove triangles congruent are AAA, you can't call for help, and the bad word, but I am going to write it backwards. Okay, since we've talked about the ways to prove triangles congruent, we can now use the theorem CPC-TC to prove everything else in the triangle congruent. CPC-TC means if the triangles are congruent, then the corresponding parts, corresponding means in the same position on the opposite triangles, corresponding parts of the congruent triangle or triangles are congruent. What that basically means is if you prove triangles congruent using one of the 5 ways to prove triangles congruent, then you can say everything else in the triangles is also congruent, like the corresponding parts. So for example, let's just look at this proof right here on example 1. Given that segment AC is congruent to segment AR. Notice those are sides, so sides get tick marks, AC and AR. And then it says angle 1 is congruent to angle 2. So I can go ahead and mark those with arc marks. And then you always ask yourself, is there anything else they share or I can mark that is additional? Well, yeah, they have vertical angles. So those get 2 arc marks on each side. Then you're just going to look at one triangle. So I'm going to pick that left one, and I'm going to walk around it, and it's angle, angle, side. And then make sure it matches on the other triangle, angle, angle, side. Yeah, it matches. So it says, what triangle congruence proof proves them congruent? Well, angle, angle, side does, which is awesome. Okay, so since I have proven that these triangles are congruent, now I can say all of the corresponding parts are congruent. So if you look at the picture, like right now I only have 2 angles marked in the side, so I can complete the picture. So I can say CL is congruent to what's its corresponding side? Well, RS, right? Because if you were to reflect those, that would match up. So CL, segment CL, is congruent to segment RS. There's another segment that's not marked. Segment LA can also be corresponding to segment SA. Okay, so then we write that one. Segment LA is congruent to segment SA. And then I have one angle that's not marked yet, which is angle 3. And what's angle 3's corresponding angle? Well, angle 4. And we can say that by using CPCTC. So everything else becomes congruent. Those corresponding parts become congruent when you can prove that the triangles are congruent by angle, side, angle, 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 side, 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 SAS, or HL. Okay, let's try example 2. Example 2, it doesn't give me a given, but things are already marked. Just a reminder that if the left side is 90 and this is a straight segment, then I can also say the right side is 90. So that's already kind of given. And then from there you ask, is there anything else I can mark or they share that isn't already marked? Well, yeah, the shared side, CX. So I'm going to give it 2 tick marks. I'm going to walk around one of my triangles. So I have, let's see, side, side, angle. Uh-oh, that is a bad word, right? Side, side, angle makes it a bad word. So it is not a congruency statement. However, if I have a 90-degree angle and across from the 90-degree angle is marked, which it is, which that's my hypotenuse, and then another side's marked, that's a leg. So this one does work because of HL. Awesome. So triangle CAX, let's match it with triangle. So we started at top C, went out to A, and then into X. So I'm going to have to go CBX by hypotenuse leg. All right. Now, since that's true, I can say all the corresponding parts are now congruent. So what's not already marked? Well, angle 1 and angle 2 are corresponding. Let's see, side AX gets 3 and side BX gets 3. So AX is congruent to BX. Oh, and then I still have angle A is congruent to angle B. That's still one I need to take care of. And all of those are true because corresponding parts of congruent triangles are congruent, CPCTC. All right, let's go ahead and head over to the next page. Write a 2-column proof for each of the following. Be sure to show all steps to prove the triangle is congruent. So let's go ahead, and we have practice with this. We're going to write down our given. Segment WZ is parallel to segment XY, and segment WZ is congruent to segment XY. That is given. If it states it in the proof, then I can go ahead and mark it. So notice there's not hints here. It doesn't say this bisects this, or this is a midpoint of this. Okay, it actually states what I have. So WZ is parallel. Parallel is our arrows. So WZ is an arrow and XY is an arrow. And then it also said side WZ is equal to side XY. So sides get tick marks. Okay. And then if you highlight each triangle separately, and some of you might already be able to see it, is there anything where your highlight overlaps that they share? Yeah, they share a side. So side XZ is on both triangles, so I can give it 2 tick marks. So step 2 is side XZ is congruent to side XZ. It's the same thing. And if you use your cheat sheet, things that are the same are called reflexive property of congruence. Okay. Whenever you have parallel lines, there should be some sort of Z, right? So if you highlight those parallel lines, and then you connect to that transversal, which is the inside of the Z, you're going to look for the corners of the Z, and those are always what kind of angles? Should be alternate interior. The corners of the Z are angle 2 and angle 1. And if you mark it, you have to write it. So step 3 is angle 2 is congruent to angle 1 because alternate interior angles are congruent. And we know that when we have parallel lines. So if you see parallel lines, there's a good chance you have alternate interior angles or corresponding angles. Okay, guys, now I have 3 marks on each triangle. So I'm just going to look at my yellow triangle right now. I have a side, there's a tick mark, then I have an angle, and then I have a side. So SAS is one of my congruency statements. Let's check it on the other side. I have a side, then I have an angle, and then I have a side. So that checks out. Just a reminder, the arrows don't matter when you go to try to prove triangle congruence because parallel has nothing to do with side, angle, or anything to that sort. So step 4, you're going to notice in the prove, it doesn't tell me to prove triangles congruent. It has me proving angles congruent. So that's going to be my CPCTC step at the end. So I'm going to go ahead and say triangle WZX is congruent to, and we have to match it, so it would be triangle, I went from W into Z out to X, and then I need to go from Y into X and then out to Z. And they were congruent because of side, angle, side. And now, since I proved that the triangles are congruent, I can say all the corresponding angles and sides are also congruent. So I can finish it with angle W is congruent to angle Y because of CPCTC. And I want to mark it before I end. So I've already used 1 arc mark, so I need 2 arc marks on W and Y. Okay, good job, guys. I'm so proud of us for powering through. We just have 1 more left today. We can do it. All right, side or segment QK is congruent to segment QA. Segment QB bisects angle KQA, and I'm trying to prove angle K is congruent to angle A. Notice again that I don't have triangles congruent to triangles, so I know I'm going to have to do that before I finish the proof. Okay, let's go ahead and start with the given. If we look at the given, you're going to notice there's really only one thing that says this equals this. The other thing is a hint, okay? So side QK is equal to side QA. Sides get tick marks. I can actually mark that one because that one says this equals this. This guy right here, QB bisects angle KQA, that's a hint. So QB bisects, just remember bisects means to cut in half, and it cuts an angle in half. Remember, the angle is always in the middle, so KQA is being cut in half by QB. So angle Q is being cut in half, so I can use my little arc marks to cut that in half. And then if I mark it, I do have to write it. And just a reminder, you can't say angle Q equals angle Q because you're not identifying what side the Q is. So let's do the top of the Q. I have KQB, so angle KQB is congruent to angle AQB. And if you look at your cheat sheet, and it's also in the given with the hint, that is definition of bisector. Okay. All right, I have nothing else in the given that can help me with markings. So then you have to ask yourself, is there anything you see that they share? Yeah, they share QB, right? And that's a side, so it gets 2 tick marks. And if I mark it, then I have to write it. So we have segment QB is congruent to segment QB. And again, if you look at your cheat sheet, anything that equals itself, it's called reflexive property of congruence. We're on a great track because if you look at one triangle, they have 3 markings. So let's just look at the top triangle, KQB. I have a side, then an angle, then a side. That checks out. SAS is an option. Let's look at the bottom triangle. I have a side and an angle and then a side. So they match, which is good. I need them to match. So my step 4 is I'm going to prove the triangles are congruent by side, angle, side. So then I can use CPCTC to finish out my proof. Okay, so triangle KQB is congruent to, and remember we have to match it. So we went from K to Q to B, so triangle A to Q to B. And they are equal because of side, angle, side. Now, since I know my triangles are congruent, I can mark all of the corresponding parts congruent. But in the proof, it just wants me to mark that K is congruent to A. And so I can finish my proof as angle K is congruent to angle A. And I know that because of corresponding parts of congruent triangles are congruent. Okay, guys, you have finished today's lesson. We are at the end of chapter 5. I'm so proud of everybody for making it through the proof and the proofs for this chapter. If you have any questions, just feel free to come in and ask any of us math teachers. And if you ever need to pause the video or rewatch the video, I try to make them fairly short so they aren't super long. Have a great day. See ya.